Hi, I'm Luca Pennati from KTH Institute of Technology, Stockholm. Here we present molecular dynamics simulations on multiple GPUs with deep potentials in GROMACS. GROMACS is a popular molecular dynamics engine, is highly optimized, and conventionally relies on classical force fields. Classical molecular dynamics is very efficient, however, it cannot fully capture quantum effects such as bond breaking, bond forming, and charge transfer. For this reason, machine learning interatomic potentials, MLIPs, that are trained on quantum data are becoming very popular, since they provide ab initio accuracy and they can represent quantum effect without the cost of actual ab initio molecular dynamics. However, integrating MLIPs in existing engines such as GROMACS is not trivial. In particular, these models have a very high memory footprint, and therefore distributed inference on multiple GPUs is required. In this work, we coupled GROMACS with DPMDKit, which is a popular framework for deep potentials. To allow distributed inference on multiple GPUs without the need of an intrusive code refactoring, we introduced a virtual domain decomposition such that each MPI rank builds its own subsystem and performs the DPMD inference task on its own GPU independently. We tested our implementation on a 15,000 atom protein on both AMD and NVIDIA GPUs, scaling up to 32 devices. In our experiments, we measured similar performance on both GPU architectures, and in particular, we measured the scaling efficiency for both strong and weak scaling of about 40% of 32 devices. We identify the number of ghost atoms as the main limiting factor for scaling efficiency. Detailed profiling showed that the dominant cost is by far the DPMD inference task, and we also note load imbalance across MPO ranks that can affect the simulation performance. Our results show that distributed molecular dynamics simulation on multiple GPUs with deep potentials are feasible on GROMACS. If you are interested in our work and would like further information, please don't hesitate to contact us.